Hi, we're Team Ingenuity. We tackle Challenge 1 at Project Hack 18. Team Ingenuity is made of myself, Sam, Christian, Zach, Ziad, Sabrina, and Aris, all from PA Consulting. This is the overview of Challenge 1. It was looking at a series of link steps and a progress tracker for that, and then the ability to report on an overall plan. We were given a number of personas and user stories, so one for a project manager, a team leader, and a team member. In response to these user stories, we developed the Ingenuity Pathfinder tool designed to monitor and report and optimize project planning and delivery. Our collaborative tool offers predictive data analytics based on historic data for early intervention to prevent non-forecast project delays. It used machine learning, real human input, and statistical analysis to improve forecasts. Given the timescales, we narrowed down the scope of the project, focusing on a solution that assumed resource leveling. We also assumed that all resources are 100% available, tasks were sequential, and only one resource can be assigned to one task. Developed a process that involved a mixture of an MS list, so a progress tracking tool that could be then exported into a CSV, and then using Python modeling, Streamlit, we'd use statistics and machine learning to generate an automated dashboard for the team leader and the project manager to track progress. We're now briefly going to a demo of the tools. This is the progress tracking tool on Microsoft Lists. So everything highlighted in purple is what the team leader or the project manager would input to begin with to set up the task, and it can also be assigned to individuals based on Outlook contacts. So the planned start date and the planned duration would feed into a calculated column here for the planned end date. Once users have been assigned the task, they can update on progress in this tool too, and record progress. When actual start dates and completions and actual completion dates have been put in, this will then feed into the overall Python model, which will update the forecast completion dates.
We have built a web application with a functional dashboard, a progress tracker, progress chart, and Gantt chart resource tool. It's a web app allowing for automated readjustment of forecast completion dates. First page shows the title of the application. The second page is the table of data we have been using, showing all the features of the assigned tasks, depending on the requests or the work streams. The third page shows a visualization of the initial project plan, plotting the cumulative working days on a timeline. This is the blue curve. The completion graph is also dynamic and shows the forecast completion compared to the initial planned baseline, and this is the green curve. The cloud around the initial forecast or the initial project plan in blue shows the uncertainty, assuming that we have 5% baseline and it's applied to each task's forecasted completion date. It has the potential to update dynamically based on historical data using two different approaches. The first one is statistical analysis, and the second one is machine learning regression. The machine learning regression model takes into account historical completion time in addition to historical resource performance. We can see per task the mean required days for the whole work stream right here. This is based on statistical analysis as well as the standard deviation related to this mean required time. And this same estimation here is based on machine learning regression.
Further down, we have the Gantt chart, which is here, which tracks the progress shown in a percentage associated with individual task and the overall task. Here we have the drop-down menu, which we can select different work streams as well as different resources or workers, and the charts are updated accordingly, as well as the statistical analysis and the machine learning forecasted completion time.
Just moving on to the judges' questions. First question, how would you flag likely delays and how would this be fed back to the user? So those who are assigned the task are responsible for updating task progress, which is then reflected in the automated Gantt chart. And as completion dates are added to the progress tracker, this then updates the forecast completion dates for subsequent tasks, which will indicate overall slippage. There's also an opportunity to develop the tool further, whereby a prompt is automatically sent to the person assigning a task to update progress. The second question covers user experience, something we have considered as a team. For example, we decided on a really simple tool that is part of the Microsoft suite, which is a tool familiar to many and also integrates really well with other Microsoft platforms. We've also reduced the amount of manual input required and highlighted in purple where different users need to be inputting data in the progress tracking tool. We've also decided on a dashboard, which is a generated web app and allows for filtering between work streams and requests. We have considered a number of development opportunities for our solution. I won't read them out all, but just to highlight a few. So the first one would be expanding our historical database by adding additional project, programs, and portfolio resource and planning data. This would help improve forecast accuracy over time. We also recommend incorporating dashboard functionality into the web-based tool, showing key metrics to facilitate decision-making for the project manager, and also expanding the tool to allow for predictive resource smoothing. So, for example, adding, removing, and reshuffling resources using machine learning.